But next up, we have Harald Fuchs from Fraunhofer IIS. Harald and I had the pleasure collaborating on an object-based experiment going all the way back to 2011, where we applied early versions of Fraunhofer's technology to the Wimbledon Tennis Championships to allow the audience to obtain control of the dialogue and adjust the commentary level over the court sound effects and combine stereo and mono. But things have moved on a long way since then. MPEG-H is now a true international standard. As I'm sure many of you are aware, it launched as part of the next generation of broadcasting services in Korea around the Winter Olympics. So it's live and on air. And to explain the intricacies and capabilities of MPEG-H audio, Harald Fuchs.
Thank you. Thank you, Simon. So I want to go into a little bit more detail with regards to MPEG-H, especially focusing on TV broadcasting. MPEG-H as a next-generation audio codec offers new features in the direction of interactivity, so to enable users to personalize the audio presentation, immersion, so it enables 3D sound to several playout systems from speakers to soundbars, binaural to headphones, and universal delivery, so one stream can be delivered to any device and the device makes the best possible sound experience from that. MPEG-H is part of all the relevant broadcasting and streaming standards, so starting from the DVB toolbox for DVB-based systems, ATSC 3.0 already mentioned, TTA, that's the Korean standardization organization that was responsible for the Korean UHD DTT system that is based on ATSC 3.0. Then towards hybrid, it's part of the recent HBB-TV 202 version. And then in all the streaming standards, so DVB-IF, CTA Wave. And to a little bit outside of the TV world, it's also part for VR of the MPEG-I OMAF standards. A little bit more on South Korea. So it was actually already last year in May when the system went on air, not only for the Winter Olympics this year. So the regular service is on air since May last year. Launched first in the Seoul area, but since end of last year also in many other areas of the country, and nationwide coverage is planned for 2020. Yeah, you can see here the roadmap. There's quite a long transition period planned in Korea. The existing HD service will continue until 2027, and they have simulcast until then. On UHD, all the three major broadcasters in Korea, that's KBS, SBS, and MBC, have 4 UHD channels on air, as I said, since last year. And what you can see here is on the left-hand side an OB van from MBC that's equipped with height speakers so that they are enabled to produce immersive sound on site. And on the right-hand side, that's an example from a studio at SBS with a 714 system. Fraunhofer supports the Korean broadcasters with a demo and training center in Seoul. So we did set up a room there with playback system, 714, and sound bar as immersive playout. And there is a complete real-time production chain and broadcast chain so that the sound engineers can be trained to work with the new system, and we offer their training and on-site support. From a device perspective, everything is there and on the market, from the production tools to encoding, broadcast encoding devices, and consumer electronic devices and SFC support. Devices are in the shop since last year. So that was a quick overview of the current status in the market. I would give a brief overview of the technical features, especially in the direction of personalization, what you can do with the object-based nature of the codec. But as a start, and I think that was also mentioned or in the previous talks, with NGA, we don't talk only about a codec, it's more like a complete audio system, so there's more to it than the compression of a single signal. It's a complete audio system in a sense of you need a renderer and a downmix system to be able to address all the different playout systems from all the different content layouts that are possible. And there is a much more capable loudness and DSC solution part of the standard, also to be able to address different playout systems from high-end systems to noisy environments. And from a personalization point of view, you can have many different versions from within one audio stream, so multi-language, audio description, dialogue enhancement for the accessibility services. And if you would want to do all those different versions with an traditional codec, you would need to deliver or simulcast many versions, which would be which would need a much higher bit rate than what you can do with reusing the objects within an MPEG-H audio scene. So if you want to go in that direction, you also can reduce quite substantially the audio bit rate. And finally, it supports all the content formats, so from channel signals to objects to HOA scene-based audio and any combination of those. Of course, if you want to be able to decode and render that in real time, there are some limitations, and those are defined in MPEG typically in levels, so as in all the MPEG standards. So for MPEG-H, what we use is the low complexity profile, level 3. And this has a target of TV broadcast sampling rate. Maximum sampling rate of the level 3 is 48 kilohertz. Then the important number is 16 signals can be decoded in a level 3 decoder, and you can use that for objects, for channel signals, for HOA transmission channels, or any combination, as long as the 16 is not exceeded. And there are some examples here, what you can do with the 16, and you can also see the 32 here. That means there can be even more signals in the stream. If you think of a multi-language program, only one of those languages is allowed to be played out at the same time. So that's why it's possible to have actually more objects or signals in a broadcast stream. And as a playout system, the maximum is 12 channels, so that's 7, 1 plus 4. So towards personalization, there are 2 levels of how you could present different versions of the audio to the user. The first level are the so-called presets in MPEG-H, and that is you can offer different versions of the audio to the user, give it a tag, a name, and those are then can be selected by the user. And if users want to go into more detail, there is advanced interactivity, where more things can be offered, like manually selecting different language versions of the dialogues, adjusting the gain of objects, pushing the dialogue a little bit more for dialogue enhancement, for instance, or moving objects around. I will come back to that with some examples. A brief outlook to what we also have in the demo that you can have a look in the break is that's how user interface could look like. So first level of user interaction is the preset menu, where you can select between the different versions. And the next would be an advanced menu, where you can then manually select languages, have some dialogue enhancement, change the balance between dialogue and background, or especially towards sports programs, you can select additional tracks, like in car racing, the team radio. You can move, for instance, the commentary to another loudspeaker if you like. If it's the stadium announcer, you could push it upwards if you have a 3D sound system. You can manually adjust the gain of different objects. But maybe important also to mention is that whatever the user is allowed to do here, that's controlled by metadata, and so is under control by the broadcaster. So only what the broadcaster allows to do, that is offered in the user interface to the user, and that is not only towards what objects the user can interact with, but also what the range is, for instance, in terms of gain interactivity or moving objects around. So that's all controlled by metadata in the stream. Bit more detail on accessibility features. So if you have the dialogue as a separate object, you can offer to the user to have a different mix of dialogue to the background signal, to channel bed. And that does not need to be a static mix. You can offer, as I have shown in the previous screenshots, also the option to adjust the dialogue to his personal needs. And that's an accessibility feature that's only possible with an object-based system. So that's not possible from a final channel mix as you have it today. And what's also an advantage of an object-based system is if you have a multi-language program, you don't need to offer final mixes of audio description and non-audio description for every language. You can have audio description as a separate object in the stream, and then the device selects to switch it on and off based on user preferences, be it automatically or manually by the user. So there are more new features that you can do with object-based in terms of accessibility, but also existing features like audio description can be enhanced. And one example, what you can do in terms of audio description is you can offer the user the option to move the audio description to a different loudspeaker, so that not all dialogue and the audio description is in the center channel, but for instance, the dialogue is in the center channel, and the user can push the audio description to left, or in a surround system even to the back, so that it more feels like that the narration comes from the side, and it can be better distinguished between main dialogue and audio description. So we have all those nice personalization features, but what happens if we have a TV set and want to connect it to a sound bar, for instance, or an AVR for immersive sound? We still want to have the one remote control to control the personalization that we also use for channel switching. So all the user interaction with the audio needs to happen with in the TV set. But the TV set doesn't decode. Decoding should happen on the AVR, on the soundbar. And the solution that is also part of the MPEG-H standard is that the TV set just uses the metadata from the audio stream to set up the UI, and if the user is changing something, a new metadata command is generated that is also standardized how that looks like, and this command is then inserted into the bit stream, and the bit stream goes to the AVR or soundbar through HDMI, so that the TV does not need to decode. It just passes the bit stream through to the external device, and if there is a user interaction, then a new command is inserted into the bit stream. And as this is standardized, all decoders in external devices know what to do with that additional command and just act passively on that command and use it while decoding. And with that solution, you can have a distributed system of TV set with a user interface and an external decoder and soundbar or AVR. So that's so much to the user end, and then a little bit towards the production side. For production, there's on the one hand the live production, where there are MPEG-H authoring and monitoring units that are integrated into the SDI workflows and also used for monitoring and rendering during productions and for post-production. And that was already also mentioned in the previous talks, used within the ORPHEUS project, plugins for workstations and also standalone tool that we have as a reference tool to generate the MPEG-H metadata. On the SDI workflow, just briefly, of course, everything can be used without metadata, so you can use MPEG-H also for fixed configurations. And then it would just be done as today, and you have your new codec in the emission. More interesting is a second stage, where in addition you have the authoring and monitoring unit, and this additional new device is then used to generate the metadata, to author the scenes, and what you will have then on the output of this device is SDI with 16 channels audio, for instance, where one of those is used for metadata and to carry the metadata. Michael already mentioned that previously in his overview. So that's also the main delivery method in traditional SDI workflows in a TV environment. And that's what we call control track, and this is basically an audio signal that carries the metadata and is very robust against resampling and level changes. On file-based, there are plugins for audio workstations under development, Spatial Audio Designer plugin, the Spatial plugin. Just to mention those briefly, then there is an MPEG-H audio native export in the Paramix audio workstation. And I mentioned that that's the authoring tool that you can use for a ready production, for production that's already done. Afterwards, you can add the MPEG-H metadata to it. To conclude, so MPEG-H audio as a next generation audio codec that is object-based, enables personalization, enhanced accessibility services and immersive sound, and MPEG-H is ready for the market, so it is supported in all the major broadcast and streaming standards. There is already broad device support from professional equipment to consumer electronics, and that's growing. And it's ready for today's and future production workflows, and it is already on air in Korea 24/7. Thank you.
Harald, thank you very much. Brilliant timekeeping as well. You've got that all in there. This is where my BBC training kicks in, and we have to be balanced and impartial, obviously, as a public sector broadcaster. It's worth mentioning that both the ATSC standard and DVB include Dolby's AC4 technology known as Atmos, and in DVB we're working on including DTS's X technology in the toolbox, but obviously today is about Orpheus, and MPEG-H was very much part of that, that project. Does anybody have any questions for Harald? Florian.
Thank you. I have actually 3 questions. The first is you mentioned that you can use up to 16 signals, let's put it that way, 16 channels or 12 channels in 4 objects. And then you said 6th order ambisonics in 4 objects. Yes. 6th order ambisonics needs 49 channels, plus 4 objects is 53. So how do you do that?
So the MPEG, so I'm not an HOA expert, but as far as I understand, there are technologies standardized in MPEG-H where you can extract, or that can be done by the encoder, extract the dominant signals of an HOA scene, and the rest of the 49, for instance, is then encoded in a parametric way, so that you need much less transport channels for the delivery than you would need from the full order.
Okay, so it's a kind of spatial sampling of higher order ambisonics. Okay, thank you. The next question is about the dialogue enhancement. Is there also a possibility to send EQ profiles, for instance, that you can boost the high frequency for elderly people, not only the level, but also change the frequency response? Because as you know, high frequency capability of hearing degrades with age, so you would have profiles like 20 to 40 years of age, 40 to 60, 60 to 2000, and then you choose the amount of HF lift.
So again, I'm not an expert on that part, but I think that's possible with the multiband DSC. So it can be different DSC streams accompanied, so dynamic range compression streams with the encoded signals. Could be that those can be used.
But it would be just for one object, you know, EQ for one object, yeah. So
for the dialogue, yes.
Yeah, for
but
instance,
also you can have the DSC on the complete mix, so on all the different presets. So you can have it on the objects and on the presets as the final mixes.
All right, so that's a little bit like this, through a couple of roads. And the last question is there a possibility for some dynamic kind of ducking, as it's called in radio? For instance, if you exchange language 1 with audio description, for instance, of course they are not synchronous. You know, the AD description is at different times as the commentary. Yes. And in TV broadcasting now, we actually do really mix music and effects when the commentary comes in, or when audio description comes in, just like at the Eurovision Song Contest a couple of days ago. So in order to replicate that with just transmitting a 5.1 bed and having the possibility to exchange language 1, language 2, audio description, a kind of mixing, automatic mixing would have to be in place. Is that taken care of?
So from a standards perspective, you can attach to every dialogue different ducking sequence that will then be used on the bed. Okay. So that you can
also with kind of dynamic properties like how fast and how fast is the the time back up to the
Good
original
detailed
level?
questions. I believe so. But again, I'm not the expert on all the details.
I think this is moving from questioning to cross-examination.
Yeah,
I'm sorry, but these are the burning
yeah.
questions.
I think this is
I need to
a
learn
detailed examination, perhaps, for the networking break. Sorry.
I need to learn a little bit more of the details, I feel.
Yeah. I'm sure there's a huge manual on the internet.
Okay, I'm sorry,
somewhere.
I'm stopping. Yeah.
That's great. I love the idea of doing a kind of EQ for people with a hearing profile. It's going to sound like all the announcers have been breathing helium, I suspect. Does anybody else have a question? Right, okay. I think I'm going to get myself carried off by the large guys in a minute because we probably don't have time for this. But if we grab one more from the audience and then we'll get onto Michael's glowering at me. But it's interesting to hear what you guys have to say. So if we can make it quick, we'll get one more in and then we'll get onto the lightning presentations.
Matthias Nitschke from Munich. The dialogue track I would rarely actually want to deliver in mono. Can I change can I deliver dialogue in a multi-channel format?
You can also have a dialogue in stereo.
Yeah.
That's possible, as long as in total you don't exceed the 16 signals. So, of course, if you have to manage your total number of signals. But yes, from standards perspective, you can have dialogue signals or even in stereo or most channels. Yes.
In any okay.
Yeah.
Harold, thank you very much. I'm sure there are loads more questions, but unfortunately we're out of time and we've got to move. I'm being overruled. I'm loving this. Go for it, Thomas. Go on.
Thank you. Mark Ross-Smith from Sky. I wondered if you might expand briefly on some representative bit rates for specifically MPEG-H level 3, LC level 3, but also the lowest common denominator for carrying a few objects.
Yeah, that depends on your signal layout, of course. But if we talk about of 5.1, it is in the same range as HEAC, a little bit lower, so maybe 144 for a very good quality. But another interesting data point might be the bit rates that you're used to from AC3. So 384 to 448, that's good for a 514 with 2 or 3 objects, I believe. But in the details, it depends on what you want to deliver. If it's immersive plus objects, or if it's a stereo plus objects. So, maybe those are 2 interesting data points.
So amazingly flexible, really.
Yes.
Yeah.
Yes. And that's part of the object-based nature, I think. There's no need to have only one signal combination and one bit rate. You need to think a bit more flexible also on that end, maybe, on the bit rate end, for the multiplex systems.
Excellent. Harold, thank you very much. I think we do have to leave it there. So,
yep.